Hi, this is Stephen Brower from Rat Rally Community College. This is for CSIT 256, Computer Architecture and Assembly Language. And this demo, just peek back here a second, this is the one that's up in Canvas that's about the jump above and jump above equal for unsigned values. Whoops, sorry. Let me run this. And then we'll go back and take a look, and we'll see what's going on. So the idea is I have a car that initially is not moving, and then what I do is I keep trying to accelerate the car, and if you notice, I max out. I can't go faster than, this only goes 5 miles. It only increases by 5 miles an hour at a time, but I can't go past 55 miles an hour. And then for the braking part, it will slow down by 5 miles an hour, and what will happen is that once I am going 0 and I hit the brake, I don't go any slower, so it's not subtracting 5 at that point. And so let's peeking at, oh, and by the way, just so the first loop here for the accelerate, it's calling the accelerate method, the accelerate procedure. The second one here calls the brake procedure. So let's look at the accelerate procedure. And the accelerate procedure will compare the car speed to, now the screaming here, all capital letters, that lets us know that this is a quote-unquote constant. So up, let me just scroll back to the top up here. If we were in Java, we would have a final int. So final int max speed is 55. But in assembly, those things are set up as like symbol definitions, but logically it's the same thing. And in Java, the naming convention for constants were all caps. That actually is a holdover from assembly, where the naming convention for constants were all caps. So the max speed here is a constant. And what actually happens in terms of assembly, at compile time, anywhere in the code max underscore speed is, it replaces it with 55. If I look back at that comparison that was being made here, so max speed, that is the 55. So at compile time, that's 55. This is an integer expression that's evaluated at compile time. So 55 minus 5 is 50. So what the comparers do is comparing car speed to 50. So it's comparing memory to an immediate. And then JA. Well, for unsigned, let's just go back and peek again. Sorry. Car speed is a D word, that's unsigned. So for an unsigned comparison, if we want to see something above, so is the car speed above 50? So here's the JA jump above. If it is, we skip over the adding a 5 and go to the skip accelerate, which then will end the procedure. If it's not above, if the car speed is not above, then it adds 5 to the car speed. For giggles and grins, if I begin by starting at 2 miles an hour, let's just pretend we're beginning at 2, and I look at the accelerate again. Well, when I hit 52, although 52 is less than 55, it doesn't give us that extra 3 miles an hour. It just, if we're at 52, we can't go another 5 because that would put us beyond. And then so it just will stop at that point. And so what's happening, just as a sort of a review for that, the car speed, which is 52, is being compared to the max speed of 50. Since 52 is above, it skips over the accelerate. And so that's why, even though, and this is the way I wrote it, by the way, but we're not getting an extra 3 miles an hour because of that. Okay, let me put that 2 back to 0. And so now let's look at the brake. And so for the brake, B-R-A-K-E, for the brake, first it's going to compare, is the speed already 0? And if the speed is 0, it's going to jump. So JE, this is just JE is neither signed nor unsigned. It's just the test for equality. So in other words, if this is all zeros, meaning the bits are all zeros, if they're the same, it'll jump to the done braking. Here it'll compare the speed to 5. If it is above equal, so again, these are unsigned, car speed is unsigned, so JA is an unsigned compare for jump above equal. If the speed is more than 5, it'll go to the brake car, which will subtract 5. But if the speed is not above, then it will, in this case here, so let's say it is 2 miles an hour, it'll just change the car speed to 0, and then we're done braking. So again, this is when we're 5, above equal, well, it is equal, so it does the brake car, it becomes 0. But then when we go back in and we're doing the 0, it just goes to the done braking. Sorry, if I put this back to starting at 2, oh, I'm sorry, if I put this back at starting to 2, is it too late for a refund? What we see is at this point here, when we're coming in, the speed of car is 2. So compare, is it 0? It's not. And then when we compare it to 5, jump above equal, well, 2 is not above equal, and so this will just zero out that last car speed. So when we are going 2 miles an hour and we hit the brake, then we do stop moving. And I know in terms of a consistency that my 2 parts of the program are not consistent, because when I was at 52, it didn't accelerate to 55, and here when it's 2, it is going to 0. I'm just trying to illustrate a point. Not well, but I was just trying to illustrate a point. Okay, so what's the point of all this? We have, sorry, car speed is a D word. Let's put this back to 0. Car speed is a D word. That's unsigned. And so when doing the comparisons, we have to use the unsigned conditional jumps. So the JA is an unsigned jump, and the JAE is the unsigned jump. Okay.